Okay, good morning, everybody. Today we have the pleasure to have Emanuel Martinez with us. Emanuel Martinez is a mechatronics engineer from Tec de Monterrey, and he has an excellent experience in design and manufacturing, working here as an MSc student at the University of Alberta. Welcome, Emanuel Martinez. Today we'll be talking about your life story, which is about protecting people with personal protective respirators, which you have developed together with our team. So welcome today. And I think our talk would be from 20 to 25 minutes. So please go ahead, introduce yourself and start with the presentation.
Okay, thank you so much, Rafik. Thank you, everybody. As Rafik just said, I'm Emanuel Martinez. I'm from Mexico, but I'm right now in the University of Alberta doing my master's degree with Dr. Rafik. And I'm going to present you this, which is called PROPOS. It's a personal protective respirator, and we are calling this presentation as an engineering solution to COVID-19. Let's start by saving wildlife. All right. So this project was developed here in Canada while the pandemic started, and it was here on the Linda Lab in the University of Alberta. So let me just start. Okay. So just before everything else, I just want to say thanks to NSAR, to Alberta Innovates, to Flexing Services, and Action ACAM, who support us on this project. And I want to mention that this project is in honor to the loved ones. Sadly, we had some loss in this year. Wali Ahmad was Rafik's brother, and he passed away on the age of 47. And my mother as well, Patricia Villanueva, she passed away at the age of 61. So all this work that we have done is in honor to them. All right. So the origin of this project, the purpose, was because of the pandemic, the coronavirus pandemic that happened. So this started on 2020. Well, the origin is actually 2019, but we actually present that on 2020, right? So for us, and from my perspective, in the story of how I live it, is my first couple of months here in Canada doing my master. And now from the student on March 5th, I get this mail from the university saying like, oh, there is this virus that might affect us. And then just a couple of days later, all classes and exams were suspended. So it was really shocking for us in this scenario. Like, it's not something that you usually do. And what was even more shocking was this news that Rafik was sharing with the team, is that in Italy, in the very first month of the pandemic, sadly around 200 healthcare workers passed away. And that's when we start to worry about, like, if these health workers, doctors, nurses are the ones that are dying first, who is going to protect us? Who is going to save our lives? So that's why we say, okay, let's do something. Let's start by saving one life. And I still remember the message that Rafik sent to all the team. And when I got it, he was just saying like, hey guys, we have the knowledge, we have a bunch of equipment, and we have the talent. Let's gather around and see what we could do. And that's why we gather a couple of people of the team, Dr. Rafik Ahmad, myself, Pablo Martinez, Rabia, David, Abraham, or even Harsha. So we gather and we start to brainstorming, thinking on what could we do against COVID, like with the technology that we have, like 3D printing, visual recognition. And then at the same time, we were thinking on like, okay, what about ventilators, respirators? And we were concerned about components because in that moment, this happened around March 2020, and even buying something small from Amazon, now it was taking 1 month or even more to arrive. So we were really concerned and thinking on a bunch of things, like what could we do? This little list is just one part of what we were brainstorming. And at the end, we decided to go for the respirators, and I was the main lead on that way. So for us, the requirements that we decided for a respirator was to have, it has to be a respirator that will help on prevent the COVID-19 virus or the particle. So we needed to have one COVID-19 filter somehow. Uh, it requires to give 4.5 CFMs or cubic feet per minute, so you don't suffocate the person that is going to be wearing that. We would like to have a defogging feature. We wanted to be ergonomic. We wanted that the mask that you are going to be using will have like 180 vision as is a normal one. It has to last 12 hours because that's usually the span for the shifts of any healthcare workers. And we were thinking on having a really quick replacement of the filter and the battery. So here is one of the very first prototypes or concepts that we had, but we iterate through a lot of them. So here are just some of the examples that I was designing in that time and that we were trying to test. And even in the very beginning, we were using this snorkel mask because it was the simplest thing at hand. And so we just gathered a couple of them, and then we were lucky that we got some attentions to the news. CTV News went to our lab to watch our very first prototype, and then afterwards, like we got even more attention, and we appeared in different um, news and even in the university webpage, and even in Mexico. Like what I had one podcast when I was talking about this design, and we were really happy about the all the attention that we got. So if you do a really good job, people will say it. Anyway, so the very first step then was to find the filter. In this case, Action ACAM was the one that gave us the filter. It's called an A95 filter. So the really good part of this filter, aside, I mean, in top of doing on preventing any COVID particle to pass through, is that it is washable. So even one single filter could last around 1 month because you could just simply wash it as a normal piece of cloth. And that is a huge improvement because um, as you might remember on the pandemic, like even just finding face masks was really difficult, and there were shortages everywhere, like even on the toilet paper that happened. So having a filter that could last a greater period of time than just a couple of hours is a huge improvement, and that's why we were really happy and we started to use this filter. However, we struggle because this filter is incredibly dense, so it doesn't allow the airflow to be really high. And that's one of the main struggles that we had. We have the airflow struggle, we have an struggle with the hose that we require, and the ergonomic mask. So to begin with, this is just a comparison of the one of the concepts that we have with a different filter. So in one, we were using a face mask as a filter that was working pretty good. We got around 6 CFMs. But once we replaced that with the A95 filter, it dropped to less than that one CFM. So it like was practically given no air pressure at all. And this measurement was just at the end of fitting of the respirator. So it still has to go through the hose and then reach the mask. So we saw that it will not work really easily. And we were struggling, and we even test to have a bunch of fans and series to try to push the air through this respirator through the hose and all that. But it didn't work. So here is just one picture on when we were using like 4 or 6 of them. And plus the device was becoming bulky. It was something like this huge, and it wasn't that good, and it was draining the battery, which we wanted to last like 12 hours. And yet, even this case, we couldn't achieve to have uh, more than 1.5 CFX. So it wasn't feasible, and like this was the main struggle that we had. Um, but we were able to overcome this thanks to the blowers, because what we saw is that we have an eggshell blower, and then we find out that what we need was to have a high pressure fan, which in this case is a centrifugal blower. So this little device, what it does is it takes the air, and with the centrifugal force compress the air and then push it, and that's why it gives you a high pressure airflow. And actually you could see these devices in vacuums, you could see that on fans for industrial applications and all that, and this is the main reason of why they are applied here. So the second one that we had was the hose, because uh, we were testing a lot of it, like depending on the diameter that you will have, it will change the airflow at the end of on the mask. If it was too stiff, if whenever you will move, the hose will move your mask as well. And if it was incredibly soft, it will collapse and then it won't let any air to pass. It was a headache, so we were comparing and testing a lot of different houses that at the same time were at hand, because there were shortages of everything everywhere, and it is not that easy to find one really good house. But at the end we were able to find one, the blue that you could see here actually. And the other one was the mask, because we didn't see anything on the field. So we used the, thanks to the 3D scan, we were using this face of one person, then start to design the ergonomics of the mask around that. And as you can see, we iterate a little bit, like we have different steps where we were changing the design, changing the features, the angle of the connector, like all those sort of things, we were changing them. And actually, Dr. Giovanni Ferreira, he helped us out. He's an expert on lung diseases, tuberculosis, and he has really good experience. And we gave him one of the samples of the mask, the respirator that we were working on. He took it like one entire day with him, and he gave us a list of feedback of what we could improve, and we gathered that data and applied that to our design. So at the end, we have this respirator, which we call PROPOS 1, and is the very first functional respirator that we had. It is using 3D printing technology, and it's really comfortable to wear. So as you could see here, you could use it and have all the freedom to move around. You could be moving on the lab, on a classroom, on a hospital. It doesn't care. You won't be bothering anybody else. And you could even be using heavy equipment with that, because it is really lightweight, in less than 1.5 kilos, I think. So this is pretty comfortable. And in this design in specific, because it's the very first one for 3D printing, and as we were looking to have to help the most people around, we went and pushed to have this design on an open source paper. So here is the paper that we have on Hardware X, and you could go. Here is the link that you could see. You could go there, check out all the installations, all the information is there, and even the 3D models if you need them. And we did this because we think that well, or as our slogan is like, let's start by saving one life, right? So we are trying to save the most life as we can. And this is just in Canada. This was happening just in Alberta. But if there is somebody else in Mexico, or if there is somebody else on the other side of the globe, and he could have this data and a 3D printing, he could start and adapt his own respirator, and hopefully we could save more lives. So then we went and improved the current design, because the issue that we had on the very first design is that is designed for 3D printing, and sadly that takes around 2 days just to have one single respirator, and that doesn't work exactly. So what we have to do was to improve the model and do an improvement for injection molding. So in that way, it could be done in less than seconds. I mean, at least the design, it is that the one that we have in this Roland Street. This guy helped us out a lot. He was really good, and I thank him because he was supporting me on this design, as well as flexing services, which are a plastic manufacturing, uh, sorry, business here in Canada. So they help us out on the technology, on knowing how to do the angles, how to do the drafting, like the designs. We take them. So a couple of things that we did was split the model. Like instead of having one single body, we split that into different ones to be manufacturable. And as you could see, the original one was like really compact and all that, but we have to split that on multiple parts, so it will be easily to do. Um, and all this design is ready, but sadly there is one patent from 3M that is holding us. Hopefully we could pass that, but it's difficult at this moment. But in case that it is needed, we have already designed, so that's good from this perspective. And then we have the third model, which is PROPOS 3 or Wally Pro. In this one, the idea is to be a standalone device that could protect us well of COVID. It won't be as good as the full respirator, but has different applications. In this model, Kaibu was the student that was helping us out. Like, he did a really good job as well. And the one of the main difference on this one is that it's a standalone mask. The idea is to last most 2 hours or something, but the application is more like for a teacher, let's say, that have to give one class, and it's not exactly in a really hazard environment, or even in a worker that is having to pass by from one facility with small particles in the air, like fibers or even dust, that could prevent to happen, and which is really good. And in this one, we are aiming to use, well, we are already working on that, on using urethane and silicone casting. Here is just one example of how we are implementing the technology. The very big advantage of this model, of this technology, is that you could achieve almost close to professional, like commercial parts. So like the mass, for instance, just the silicone, the material, and that in this one is silicone compared to neoprene, which was the previous one, is more soft and even more comfortable, and the finishing is really good as well. So just to compare here, I have here the 3 models. So the very first one was the fully functional 3D printing, but using 3D printing technology. Then the second one is the Putty Pro, which is prepared for injection molding. And then the third one is the standalone using silicone and urethane casting. Now, let's say right now everybody's thinking, oh, but all the vaccines are now here on, and the COVID is almost gone and all that, what is going to happen? But however, sadly, we cannot say that it will be our last pandemic. There are some variants that are coming up, and even we don't know if something later on could happen. The good thing is that now we have at least one idea and one product to start working on, like to prevent people from passing away. And it has another industrial applications as well, like construction, textile, waste management, plastic recycling, medical, and manufacturing. So any industry that works in a harsh environment with particles in the air, it is a really good application for our respirator here. So I just want, again, just want to answer Albert Innovates, ACAM, and Flexing for all the support that has given us on this project. Thank you so much.
Thank you very much, Emanuel, for the wonderful presentation. And I completely agree that this is not our last pandemic. there will be a lot other similar kind of issues coming to the world, and I hope it's not coming, and I hope that we don't see any of them in our life, and even our kids don't see them. But sadly, it's a reality now that people know this. There will be a lot other similar kind of issues coming in. But the good thing is that thanks to this technology, we are ready. If we develop this in 1 year, the next one would be ready in 1 month. I have full confidence on people like you and the future and the future generation. And that's what we are doing, educating the futures. At the PROPOS Society, we are quite interested in educating the future to see how we can adapt ourselves to the future challenges which might be coming in the future. So I have two quick questions, and it was a long presentation, and I think it was pretty clear. You talked about many engineering challenges, but I still want to see, where do you see such kind of technology, especially if you're solving a problem which is medically oriented, when you are solving this kind of issues, what kind of transdisciplinary knowledge do you need? I'm just talking in terms of what kind of expertise were at the time when we were developing this technology we required. So either it's engineering, sciences, or whatever. So what do you think, that what kind of expertise are required if you want to make a change in the world with developing technology like this?
Well, that's a tough one, because what helped me out to me, just putting me as an example, is the knowledge that I have on my background. So I have the experience of being good at 3D modeling. That's one part. Knowing how to use a 3D printer and the development of products. So for even instance, like if you want to at some point do something on your own, it will be really good to question how everything is done. So like even just one single part here, you need to question, okay, why does it have some ribs in here? Why does it have these columns in here? And you will realize that it's not that difficult, just people sometimes doesn't take the time for that. But the knowledge of product development is more on questioning what every feature of the product has to be there, is instead of just looking into the 3D model, because it's so easily to learn 3D modeling, like, but that's not designing, because you will do that in less than 1 week, just even on YouTube, thanks to the technology right now. But just that tool by itself won't make the difference. What will make the difference will be the interest, your interest into how to develop one product, and then you will compare like whatever is on the market, doing a benchmarking and putting everything together.
And I think the most important thing that was probably the success of this project was also the motivation of the people, right? If you're not motivated, no matter if you have the technology, no matter if you know all the different softwares, no matter if you're an expert engineer, nothing will work. And that was kind of the beginning. We wanted to save one life. I don't know if we will ever save that life, or maybe we have already saved so many out there, which we will never know, but we don't even want to know. We just wanted to do our efforts, and we are pretty happy with where we are so far. My last question, it's a very general question I want to ask, and I have received this question so many times while I was talking about the PROPOS model. So I just want to ask you as well, that where did you see yourself when we were developing this whole technology for this 1 year and 1.5 year? Was there any single point where you felt that, okay, we failed, we cannot go ahead?
Oh yes.
This is probably the end of the technology, or all our efforts have gone.
Yeah, of course. Yes.
What was that
So when we got the filter and we were testing all the prototypes that we had at hand, and we saw that there was no airflow practically in that moment. It was really frustrating, and that's why I was showing the device with multiple fans in series. It was really difficult to achieve that part. It was really devastating to see that we have all this progress, because at that time we already went through 1 month of just different iterations, and we were really pushing through that, and we didn't get any airflow. So it was really shocking. And then doing some research, and I saw one. You might still remember that I saw this centrifugal fan that was on, what was the name of the store in the north of Edmonton. I just told you, like,
Memory
Rafik, you know
Express.
what? Yeah,
Memory Express. Yeah.
Emer Space. I just told you, Rafik, this is the fund that we need. It will solve our project. And, and that was, I just remembered you, like, okay, go ahead, and you just went and take that one, take to the lab. In 1 or 2 days, we were testing that already, and that one was working. And that's when we knew that it will work. I even remember sending you the message like, it worked, it worked.
Yeah, thanks a lot, Emmanuel. And I think I felt the same around that time of the project. I really felt that we probably will not succeed. There was also other really issues, big issues or small issues related to pipes and also related to funding, even where I felt that maybe will not succeed, but at least I wanted to try, and we tried, and it helped. And I think this is not the end of the project. There are so many things which are coming, and hopefully this will be for generation helping for the safety of humanity, either through manufacturing systems or different areas of our companies, or even future pandemics. So thanks a lot for all your efforts and all your help in helping the community. The product is, or the first product is especially open sourced, available to anybody to use it in the world anywhere. And we are more than happy to contact or communicate with people, help them out if they want to work on the design process. All the information on how to contact us or the website for PROPOS is already up there. So please reach us there. And thanks a lot, Emanuel, for giving us time on the weekend to educate our futures. And hopefully we will see you for some other episode at some other time.
Perfect. Thank you so much, Rafi. It was a pleasure.
Thank you. Take care. Bye.